All right, let's talk more about circles. We're going to talk circumference and arc length today. We've talked circumference a little bit before. We'll get into talking about arc length. We've talked about arc measures, but we'll talk about their lengths. It deals with circumference. So first, let's just take a look at the basics of the circumference of a circle. And as we do that, just kind of give us a comparison. We know radius and diameter. Diameter is double the radius. As we compare to circumference, we can see how that works. If we pull the circumference off the circle, we see it's 3 diameters plus a little bit more. And same would be true if we had the radius. Since radius is half of the circumference, there's going to be 6 radii plus a little bit more. So where does that number come from? Why is it always in that ratio, no matter what size the figure is? We're going to explore that and take a look at that a little bit more in depth as we talk about radians today. But there's that connection there. We call that pi. And so when we talk about a circle and its circumference, we say it's the ratio of diameter times pi. Pi is about 3.14. So 3 diameters plus a little bit more gives us our circumference. And it's true for every circle. So 2 times pi, so 2 times 3.14 is about 6.28. So about 6.28 radii gives us our circumference. And then as we talk about our arc length in a circle, arc length is just a portion of the circle. So you can kind of get an idea of that. And we got a proportion here. So the arc length compares to it would be arc length to full circumference, arc length to full circumference, which is 2 pi r, would be the same as the ratio of the arc measure, so the degrees, to a full measure of 360 degrees. So we're comparing the arc measurement, the length, to the circumference measurement in the same way that the arc measure compares to the angle measure. So we're comparing lengths to angle measures. And so if we simplify that equation, we know the arc length is equal to the measure of the arc out of 360, because what portion of 360 of the circumference are we getting? So let's take a look at an example here. Let's just start with circumference and radius, calculating that. So circumference equals 2 pi r. And if we want to calculate the circumference of a circle with radius 9, let's do example A. So I'll just say circumference equals 2 times pi times, well, radius is 9. So I'll just evaluate what I know. 2 times 9 is 18. So it's 18 pi. And that would be, what, centimeters? 18 pi centimeters. And if you want an approximation, you could use 3.14 for pi. 18 times 3.14 is approximately 56.52 centimeters. Okay, and if we knew the radius, or part B says we want to find the radius with circumference 26. So I put 26 in for circumference, and 2 times pi times radius. So in this case, I want to solve for r, so I'm going to divide by 2 pi to get r by itself. And that would give me r, so 26 divided by 2 is 13. 13 divided by pi would be my radius. And to approximate that, 13 divided by 3.14, I get about 4.14. And we're measuring in meters. So it'd be about 4.14 meters would be my radius. Now as we talk about arc length, if I got a circle that's 60 degrees, I know its arc measure will also be 60 degrees. So I want 60 out of 360. So the arc length will equal that. So arc length will equal 60 out of 360 of the circle times 2 pi r. 2 times pi times 12. because that's going to give me my circumference. So basically think of it as this way. Find your circumference, 2 times pi times 12, and we're multiplied by the fraction of the circle that we have. So 60 out of 360 is 1/6 times 2 pi times 24, or 12 is 24 pi. And 24 pi over 6 equals 4 pi. So 4 pi would be the length, or if we want to approximate that, 4 times 3.14, and we get approximately 12.56 for our arc length. Okay, so we could leave it in terms of pi, or we could approximate that. Okay, so that's our length. Don't get confused with the arc measure. It's an arc measure. This is the arc length. It tells us how far around this is, and this gives us our angle of what the central angle would be in a circle of that size. Let's take a look at another example. I know that this arc, this major arc, is 270. So I know that this angle, central angle, is 90 degrees. So this arc measure is 90 degrees as well, because I know there's 360 degrees in a circle. But if I want to find this arc, I know that the arc length, as we calculate that, I'm going to figure out what ratio of the circle do I need. Well, it's 270 out of 360, which I know is 3/4. But it's 270 out of 360 times my full circumference. I just want that portion of the circumference. My circumference is 2 times pi times 16 in this case. My radius is 16. So I can simplify that. 270 out of 360 is 3/4 times 32 pi. And when I simplify that, that's 96 pi over 4. And 96 divided by 4 equals 24. So 24 pi, or if I want to approximate it, 24 times 3.14 gives me 75.36. We don't know the units, so we'll just call it our measurement units. It's a linear measure because we're measuring distance around. So that arc length would be 24 pi or 75.36 units in that particular circle. So I'd like to discuss what is a radian. Radians and degrees go hand in hand. It just depends on what we want to measure with. So if we go over to GeoGebra, we're going to work our way through an activity here, which will teach us what a radian is and how it's connected to degrees. All right, so I'll kind of work our way through the exploration here. It says find the length of the radius of the circle. So I've got 2 radii, and we're measuring the angle between it. So the radius is a measure of 1, as we can see. We want to move point B so that the arc is the same length as the radius. So we want to get that arc length to be 1. So I'm just going to move this. You can see it calculates as I'm moving. And I've got an arc length of, what can I get, 1. See how steady I can make it. 0.99, that's pretty close. So as I get it that close, we want to see how many degrees that central angle is. It's important, 56.713. And as we take a look at that, we say that the angle formed by this arc is the length of 1 radius. So 1 radius, so this length is a radius, these are all 1, is 56.73. We call that a radian. So 1 radian equals 56.73 degrees, or 713 roughly. So a radian, as you mentioned, is the angle measure of, in the circle, when the radius is equal to the arc length. So we want to move B so it's twice the length of the radius. So I'm just going to move this so that's 2. So now my arc length is roughly 2. So there we go. Perfect. many degrees is the central angle? It's 114.592. You notice that's double what we had before. So radians, as we talked about, are an alternate unit of measurement for angles. So instead of degrees, sometimes we use radians, and we'll talk about why we use that. It has to deal with our measurement of pi. So it's a natural way of measuring the angle because based on the radius. So I say, well, this is 2 radii, 2 radians. And so radian measures the angle that's subtended, fancy word for cut out. The angle cut out by an arc on the circle exactly the length of a radius. This is 2 radii. So 2 radians, the angle cut out that cuts out a measurement of 2 radii. Let's see. So now it says change in just the slider to increase. So if we make this radius 2, we double it. Notice our arc length is 4. The arc length just doubles. So everything just doubles, but the angle measure stays the same. So it just kind of depends on the size of the circle, but the angles stay the same. If we go to a full half circle, how many degrees are in a half circle? You should know that. That's 180. Notice that how many radians that is. Look at that number, 3.145 roughly. 3.14, you know, is the approximation for pi. So a half circle is a pi in radians. A full circle, 6.28, which is double pi, which is 2 pi. So 2 pi in a full circle. So we say a full circle is 2 pi. Half a circle is 1 pi. And so we'll use that as we start talking about how to calculate in radians. So we'll get back to doing some work and calculations with that. Hopefully you gain some greater understanding of what a radian is. All right, so this information you have in your notes, this just explains how we calculate the arc length. Again, the bottom part talks about how we can convert radians and degrees. This top part deals with the length, how we find the length of that. This bottom talks about the radians that we just discovered and how we can convert back and forth between radians and degrees. It deals with the fact that we know a complete circle is 360 degrees, and it's also 2 pi radians. And it's 2 pi radians because we said that circumference of radius 1 is exactly 2 pi. So we can use that fact to convert between degrees and radians, and just we can create proportions with all this. Bearing in mind that whatever measure we're finding has 2 pi compared to 360. So as we take a look at this, if we want to convert to radians, if I know a circle is 90 degrees, what I have is 90 degrees. I know in a full circle there's 360 degrees. Well, I also know in a full circle there's 2 pi. So 90 degrees would be how many pi? And cross multiply, so figure this out here. So 360x equals 180 pi. And we want to keep this all in terms of pi. So we solve for x, we divide by 360. Divide by 360, and 180 divided by 360. 180 pi divided by 360 would give us pi over 2. So in terms of pi, 90 degrees is pi over 2 radians. You'll use a lot of work with radians as you get into Algebra 2 and pre-calc. As you start working with some more trig. Radians are degree measurement that are more exact and precise as we're dealing with graphing sine, cosine, tangent functions, and you'll work with that later on. So that's how we convert to radians. I'll give an example where we can convert to degrees. We'll take a look at this example down here. And bear in mind, I'm using proportions. If you want to convert it to an equation, that's fine, but I think sometimes our understanding with proportions helps us out a little bit. So if I have pi over 6, well, I know pi over 6 is the portion that we're looking at. I know full circle has 2 pi. And if I want to find the degrees, I want to find the degrees for this portion. So I'll put that on top. And I want to find a full circle is 360, matches up with 2 pi. So here I can multiply my cross products. So 2 pi times x is equal to 360 pi over 6. And 360 divided by 6 is 60 pi. And 2 pi over x over here. And then if I want to solve for x, I'll divide both sides by 2 pi. And when I divide both sides by 2 pi, the pi's cancel out. And I get x equal to 60 pi divided by 2 pi is 30. So 30 degrees is pi over 6. You can take the time and try these other examples, see if you can convert those, and we'll check in when you restart the video. So as we look at the first one's converting to radians, so 60 out of 360 equals x out of 2 pi. Cross products, I simplify pi over 3. 120 out of 360, well 120 is a third, that might be helpful to know. And then we get to x out of 2 pi because 2 pi is a full circle, just like 360 is a full circle. I get 240 pi over 360, which simplifies as 2 pi over 3. And then 75 degrees out of 360 was x out of 2 pi. I get 150 pi over 360, simplifies as 5 pi over 12. And notice how we can simplify and keep those in terms of pi without having to approximate. You can restart the video when you're ready to check the explanations for the conversions to degrees. Alright, so as we convert it to degrees, pi over 2 is part of 2 pi, same way that x degrees out of 360. So I get 360 pi over 2 equals 2 pi over x. Simplify that down to 180 pi, divide by 2 pi, x is 90 degrees. Now remember, a full pi is 180 degrees, so half a pi is 90. That's another way to think of it. So 3 pi over 4 out of 2 pi is x out of 360. Simplify that down and get x equals 135. Now 2 and 3 aren't in terms of pi, so we're not going to get an exact degree measurement. These will be approximations. If I take 2 out of 2 pi equals x out of 360. Get 720 equals 2 pi over x. Divided, it's exactly 360 over pi. So 360 over pi degrees is approximately 114.6. And then same thing, 3 over 2 pi equals x over 360. Simplify it down, I get exactly 540 over pi, which is approximately 171.9. So you're going to use this a lot more as you get into Algebra 2 and pre-calculus, as you start working more with trig. But it's good to see the geometry behind it and how radians are connected to the radius. So you learn how to convert those and calculate the arc length within a circle and see how that's connected to the circumference, which the formula is 2 pi r, or pi times diameter.